Hello, today we will be learning about arithmetic sequences. Now, what is an arithmetic sequence? Well, it is firstly an ordered set of numbers. So be sure to take notes while doing this. It's a really short video that will really compress everything you really need to understand on an arithmetic sequence. And an arithmetic sequence is an ordered set of numbers, and it also has a common difference, which stays consistent and constant throughout a sequence. And this is denoted in mathematics by the letter D. You can see this as an ordered set of numbers and has a common difference between each consecutive term. Now, let's firstly look at how to identify and what it actually is. So firstly, we have to see what an arithmetic sequence is. Let's just quickly see. A sequence, right, is like ordered set of numbers. Remember, it's an ordered set of numbers, and it goes up in a common difference. So, for example, a sequence can be like 1, 3, 5, and 7. Also, another sequence. Now, if you're here, the meaning of sequence is the following of one thing after another. That is what a sequence is. So this follows after another, this follows after another, this follows after. So a sequence can also be 1, 4, 5, and 7. Difference is that 3 is now 4. Weird, right? Now, the one that is an actual arithmetic sequence, it should be an ordered set of numbers. So these are ordered set of numbers, correct? Does it have a common difference? What is a common difference, you may ask? Common difference is the difference between two consecutive numbers. Consecutive numbers is before and after of a number. So after 1 is 3 and before 3 is 1, so that is consecutive. After 3 is 5 and before 5 is 3. After 3 is 7 is not correct. So if we were to say 7 and 3, are they consecutive numbers? After 3 is 5, so obviously it's not 7. After is not 7, it's 5. And before 7 is 5, so it's not 3. The consecutive numbers are 5 and 7, or they are 5 and 3, or 3 and 1. Those are what we call consecutive numbers. Now, firstly, the difference between an arithmetic sequence and a normal arithmetic sequence is that they have a common difference. What is the common difference? Well, let's say it is consistent, and it does not change. So it's constant. And it's denoted by D, right? D. Remember that. Now we have these two things here that I just made, and let's see if they have a common difference between them. So as we can notify, what is a common difference? Well, we already know difference, right? When they say the difference between of 5 and 3, understanding mathematical language is a very key, useful kind of thing you need to know when dealing with math. Now, when you're given difference, or you know how they say sum, and sum's adding, the difference is a minus. So if the sum of 5 and 3 would be 8, because you're adding 5 and you're adding 3. The difference between 5 and 3 is 2, because you're minusing, so 5 take 3 equals 2. That is the common difference. What is common? Common is it is very consistently throughout the sequence and is a constant. It does not change. That's what it means by common. And that's what it means by difference. The difference between two numbers, each consecutively. Remember that. It's consecutive. You can't find the common difference by finding 5 and 1, or 3 and 7. You cannot find the common difference. You can only find the common difference from 5 and 3, or 3 and 1, or 7 and 5. Because they are consecutively right before each other, right before or after each other. So first off, understanding mathematical language is a key thing in understanding and perfecting math. And let's identify if there are the common difference between these two sequences. Common difference between 3 and 1. So 3 take 1 is 2. So it goes up by plus 2, because 1 go plus is 2 is equal to plus 3. And it's not going negative, so you know it's going up by plus 2. 3 and 5, 5 take 3 is plus 2 again. 7 and take 5 is plus 2 again. So, we can see Is it a common? Is it a common? It's common because it is consistently and constantly the same difference. It is the difference between these two numbers are constantly and consistently the same as the difference between here and here. So you see how they're plus 2 here, and they're plus 2 here, and they're plus 2 here? They are consistently the same and constantly the same. Now, the difference is the same, because the difference is plus 2, and they're consistently staying the same. So let's see if we can find that if these are following the arithmetic sequence rules. Does it have a common difference, sorry? Let's see. This goes up by plus 3. Okay. Then this goes up by plus 1. Oh, okay. So, first off, we can see it's not consistent. And it's not constant, because it's not staying plus 3. It should be plus 3, but it's plus 1. So it's not constant, and it's not consistent. Now, consistent and constant is basically the same thing. I'm just trying to convey to you a great understanding of it, really. But I might be confusing you, because if you're given a common difference of plus 2, it will remain plus 2 for the rest of the sequence. If it changes up, like, this was supposed to be plus 3, right? If it was plus 3, and then it went up to here, and it was plus 1, that is not consistent, or let's just say consistent, or constant, right? It's not consistently the same. It does not have the common. Now, in a way, common can be written as same. It does not have the same difference. These have the same difference. They're always going up by 2. They have the same, which is 2, difference, which is the difference between these two numbers. Are they same? If we were to say this is plus 3, and this is plus 3, and this is plus 3, and then it goes to plus 1, incrementally, it is same, 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 not same. Not same. That means, since it does not apply to the common difference rule of having a common difference, this sequence does not have a common difference. Right here, this sequence right here does not have a common difference that is same, that has the same difference throughout the entire sequence, because it goes up in plus 3 and then plus 1 and then plus 2 again. That's weird. Well, not again, but yeah. That means that it is not an arithmetic sequence. Since this is orderly going in the same difference of plus 2, plus 2, plus 2, and it's an ordered set of numbers, which both of these are ordered set of numbers, since it has a common difference, which has the same difference, that is an arithmetic sequence. Now, it's cool analyzing it, but it just takes too much time. For, say, if you had like 1/4 plus something, 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 another fraction, I can't have the brain cells to think about it. If it's in fractions, you can't really calculate the common difference that easily, right? So what you can do to find the common difference, which is an equation, is D is equal to, D is the common difference, and D can be denoted by Tn take 1. So Tn take away, Tn take 1. Now these are subscripts, so they're lower than T, so you write them lower than T. So be sure to keep that in mind. Oops. So if you want to find what the common difference is, but it's in like fractions or decimals and they're hard to calculate, then to find D, you can use this equation right here. D is equal to Tn take 1 down here. And it's the n take 1 part. That's the subscript taking 1. So, for example, we're given this is term 2 and this is term 1. Now, what are terms real quick? Let's really quickly just discuss that before we move on. Alright. So, let's just do a really quick one. 1, 2, 3, and 4, and 5. Right? Tn. First of all, term is the term of a specific number. Now, you may not understand what term is, but further on when you move on with your class, you'll be able to understand what it is. But for now, I believe that we should discuss more important matters of n. Now, what is n? n is equal to number in sequence. Now this is important to understand that what it means is Tn is term of any number. It can be any number. You can replace n with any number in the world, in the sequence. So say we were trying to find d, and we will use the number in sequence n. N is equal to number in sequence. This is the first number in the sequence, right? It starts with 1. This is the second number because it goes up. This is the first number, second number, third number, fourth number, fifth number. So this is n equals 2, n equals 3. Oh, sorry. N equals 4, n equals 5. This is term 1. Because this is the first term in the sequence. This is term 2. The second number in the sequence, which is denoted as, or said as term 2. Term 3. The third number in the sequence, term 4. The fourth number in the sequence, term 5. The fifth term, or fifth number in the sequence. That is what it means. It is the number in the sequence. And given this equation of d, which is the common difference, the same difference, is equal to the term of any number. So now we know what term is. It is the placement of a specific number. So it doesn't need to be 1, 2, 3, 4. It can be 2, 4, 6, 8, right? This is still term 1. This is the first number in the sequence. So this will be T1, the first term of the sequence. The first number of the sequence, or you could say it's like that. But it's rather regarded as term 1. The first term. The second term. The third. And the fourth. And the fifth term of the sequence. What? First number, second number, third, fourth, fifth, right? So this is the fifth term. 1, 2, 3, third number. This means it's the third term. Very simple to grasp that concept. Now, so you know what term is, you know what the number in sequence is now, so, and you know that this is a subscript intake one. So it's not like this, right? If we were to say Tn and Tn, we replace n with a number in sequence, we replace n with n equals 2. N equals 2 is 2. We don't do 2 take 1, which is 2 take 1. We do not do that. Instead, what it means by take 1 of the subscript means that if we were to replace n with 2, which is 2t2 take 1, which will equal to t1, because it's 2 take 1. The subscript is 2 take 1, which makes it the first term. It is not taking 1 off of the answer of what t2 is, but it's actually taking 1 off of the subscript, which is equal to t1, and we can see from the t1 is the first term of the sequence. We can identify that the first term in the sequence is 1. So t1 equals 1. Or t2 take 1 is equal to 1. So let's find the common difference, right? After discussing all of that. It's a bit confusing, and I know, but further on as you move on with your class, you'll be able to understand it a bit more. What is the common difference, or the same difference, between each consecutive number? Alright, so let's do a simple one. Let's do the fourth term, which is 1, 2, 3, 4. Number equals 4, n equals 4. This is the fourth term. Right? And let's do the third term. 1, 2, 3, n equals 3. This is the third term. So d is equal to, alright, we'll denote this n as 4 because we're starting with 4. So we replace, since this is equal to n equals 4, we replace n with 4. Take away tn, which we know as 4, so let's write 4. Take away 1, which is written as t4. Take away t3. Now what does that mean? Well, that actually means the fourth term is taken away from the third term. And we know the fourth term, which is n equals 4, this is 1, 2, 3, 4, the n equals 4, fourth term of the sequence, because it's the fourth number of the sequence, is 4. So d is equal to 4, take away the third term, which is 3, take away 3, d is equal to positive 1. So as you can see, is it correct? Well, yes, it's going by plus 1 up here, it's going by plus 1 up here, it's going by plus 1 and plus 1. It's consistently the same, so remember, common difference is the same difference. It's the same difference, it's going up by plus 1. It's the same, and it's going up by plus 1, which is the difference. So it's the same difference, it is the common difference, so it is an arithmetic sequence. So we can confirm it is an arithmetic sequence, and we can confirm that the common difference is equal to d. Just from calculating, or just from simply looking at it. But always calculate it, because it's way safer that way. So that you won't make mistakes by accidentally observing it and not looking at it fully. Now, this is a quick, easy way to understand if it is an arithmetic sequence, but firstly, also you need to compare the common differences. So, for example, if we were to given this arithmetic sequence, so we know how to calculate the d, right? We can use any number, right? So let's just quickly delve into that, and then we'll go into the next topic. D, right, we can do, instead of t4, take t3, which is the fourth term, take third term. We can do second term, take away first term. So it's the same. 2, take 1, equals 1, positive 1. Same. Common difference is the same. Remember, the common is equal to same, it's the same difference. So it's correct. But a fatal mistake that you need to keep in check is that when you encounter stuff like this, you could say, alright, let's do this. D is equal to T2, take T1. Remember, this is the second term, because this is the second number that starts in the sequence. This is the first number. This means that it's the first term in the sequence, so equals to 2, because the second term. Take away first term, which is 1, equals 1. And you're going to be like, oh, okay, that means the common difference, which is D, is equal to 1. Wrong. You also need to compare it with another pair. So, let's compare it with this one. Now, they may trick you, so you have to use your eyes visually as well to identify if it's wrong or not. Let's do the fourth term, which is 1, 2, 3, 4. This is the fourth term. And the third term, 1, 2, 3, third term. Let's try this out. So, the fourth term, take away the third term. Remember, the equation is Tn, take Tn, take 1. This means that this number, which is T4, or any number, term of anything, will always be bigger than this number. Which means that this will always be bigger than this to take away. Now, if it's negatives, it applies correctly. Don't think too much about it. Just think that this will be a bigger term than this term. Even if it's negatives, like negative 1, negative 2, it will be negative 2 minus negative 1, because it's term of 2 minus term of 1. So even if it's negative numbers, it will still be a positive term number. So term 2, take term 1. And then you would substitute the results in, which is negative 2 and negative 1. Quick example. Anyways, 4 take 3, so we have fourth term as 6, and we have third term as 4. D is equal to 2. Now, since we know that the first attempt, D is equal to 1, and this is D equal to 2, I'll show you this much. 1 does not equal 2. It does not equal. Nope. 1 does not equal to 2. D equals 1, D equals 2. They are not common, remember? You know what common means? It just means same. The difference is not the same. This means that this is not an arithmetic sequence. 1, 2, 4, 6, 7, 8 is not an arithmetic sequence. The general formula of it. So general formula is written as term of any number is equal to the first term plus common difference, number of anything in the sequence, take 1. So, for example, if we had 2, 4, 6, 8, 10, And there's some, this is term 1, remember term 2, term 3, term 4, and this is term 5, because it's the first number, second, third, fourth, and fifth. That's why it's term 5, because it's the fifth term in the sequence, the fifth number in the sequence. Supposedly they asked the question where they're saying, find what T10 is, which we only have gone up to T5, we don't know what T10 is. So you can put this in. We know that T10 is the same as Tn. And you can see the difference is that n is now 10, so we can replace it here in the equation n as 10. So T10 equals T1 plus D. And we can replace n with 10 again, 10 take 1. Now we can identify that what is T1, the first term in the sequence. So we can see that first term in the sequence, which is term 1 over here, is 2. And we don't know what D is, but the question says that this is an arithmetic sequence. 2, 4, 6, 8, 10 is an arithmetic sequence. So if they're already given us that it's an arithmetic sequence, you don't need to really calculate, compare if D equals the same number as the other D. You can just see the common difference, which is 8, 10 take 8 is 2. So we know that D is equal to 2. We know that T1 is equal to 2. But we don't know what T10 is equal to, the 10th term in the sequence, because it only goes up to the 5th term of the sequence. So the 10th term of the sequence is equal to term 1, which is 2, plus D, which is 2, times, which is, remember your bin dash, brackets, indices, so we go do brackets first, and then there's no indices, so don't worry about that, and then there's multiplication, which, when you have a number outside of a bracket, that's basically multiply. So 10 take 1, we have to do brackets first, so bin dash, brackets, so we do brackets first, we have a bracket here, so let's do that, 10 take 1, 9. Then we don't have any indices, so we don't have to worry about it. We have multiplication because 2 bracket 9 is the same as 2 times 9. So this is actually T10 is equal to 2 plus 18 after you multiply that. So you've done that, sorry. And then there's no division, there's addition, 2 plus 18. So T10, sorry, the 10th term is equal 20. And there's no subtraction. Now, how do we double check this? Well, we already know the common difference is 2. So let's just, we already know, term 5, the 5th term of the sequence is 10. So let's just keep on adding 5 more times to get up to T10. So let's just get rid of all of this over here. So remember, we said that T10 is equal to 20, right? So let's see if that is actually correct by doing it manually. We know that the common difference between the numbers is 2, so it goes up by 2. Oh, sorry, 1 plus. These are just commas. T7, T8, and T9, and T10. So we just gotta keep on adding 2. So add 2. That's 12. Add 2. That's 14. Add 2. That's 16. Add 2. That's 18. Add 2. That's 20. T10 equals 20. T10 equals 20. Now the reason why we use the formula of Tn equals T1 plus D bracket n take 1 is because you don't have to go through this boring, long manual process of having to write it all out like this. It takes so much space, as you can see, and it's so time consuming, especially if they ask you to do T equal T100, right? You're not going to go from T5 to a T100. Instead, you can just do it the easy way and just do T1 plus D bracket n take 1, which will equal to T100 equals T1, which is 2. We know D is equal to 2, so 2 plus 2 times 99, because 100 take 1 is 99. 2 times 99, and then you just add it, and that's what T100 is. And that is how you would use the general formula of Tn. That is how, you would utilize the general formula that they give you of Tn equals T1 plus D bracket n take 1. I hope you learned something today. It may have been confusing, but one quick thing that you have to remember is that arithmetic sequences only have subtraction. and addition. So it can only, if it's like 2, 4, 6, 8, it only goes up by +2, or like +2 and +2, right? It can't do like ×2 and ×2. That's geometric sequences, and that's also part of powers in the geometric sequences, which geometric are very similar to arithmetic, but arithmetic are like pluses and subtractions and addition mainly focused on. And you will also see like minuses too, so like you will see like 7, 4, 2, and 1 or whatever. This is not an arithmetic sequence, but just keep thinking it is. It can go also going back down by -3 and -3 and -3. It can go in negatives as long as it is the same difference. Same. You see these are all same, and there's the same difference. They can go in subtraction or addition. This is the general formula. I hope you learned something here. It may be confusing, I'm definitely sure. I'm not the best tutor out here in the world, but I hope you learned something. Thank you for joining me, and next thing we'll be talking about will be the sum of arithmetic sequences, and we'll be working on some problems together a bit more so you can understand the idea of it. Thank you for listening, and have a nice day.